All right, it's recording, and I'm welcoming everyone to this another SUP46 workshop. And the purpose of this workshop series is to give you, as an entrepreneur, quick advice on how to improve your business, whatever perspective you're taking on it. And the structure is we invite experts to share their perspective on things. It's 45 minutes plus 15 minutes Q&A as always. And for best experience, make sure you keep your mic on mute when you're not speaking. And for our pleasure, we always like when you have the webcam on. So that's recommended. That will be way more enjoyable for me and Korey. And yeah, we'll add the recordings to our library and we'll share the deck as well. Also, special welcome to our friends from Scania, who is joining in to get some added input and insights. And thanks to Kat for coordinating as always. She'll keep track on the time and chat and late arrivals. And don't forget to respond to the survey that's pushed to you during the Q&A, right? And yeah, it's my pleasure to welcome today's expert, Korey, cloud advocate at Microsoft. And yeah, Korey has mentored and guided a bunch of startups through their AI challenges, and he'll share more information about his thinking. But yeah, he want to expand AI literacy, which I think is a really noble ambition. Previously worked as a solutions engineer on Klarna and worked on translations and as an AI developer advocate at Peltarion. With that said, Korey, thank you so much for joining. Leaving the floor to you. Thanks for joining.
Cool. Super happy to be here. And like you mentioned, a topic that I do love to speak about. So let's get right into it then. And I hope normally this first click is like where things fall apart. So let's see if this works. Cool. Perfect. It worked. So normally when I'm asked about doing talks about AI, I think there's like maybe 3 different categories of talks whenever we want to talk about either new audience to AI or even experienced people. And the first one I get all of the time is, oh, please show us some cool demos of AI. Because that's where the wow factor is, and that's how people get excited. So if you're only here for the demos, I'm going to give this to you very quickly, so you don't have to wait any longer. So I'll intro this one demo first. This is actually using Stable Diffusion model, which is a diffusion model, as the name is implied, and basically using not going too technical here, but some text encoding, so the model understands the text and generates some images. So be warned that this is creepy. So if you are suspect of creepy nightmares or things like that, I apologize if this is something that's going to spook you later on.
Whether the weather be cold or whether the weather be hot.
We'll be together whatever the weather, whether we like it or not.
Whether the weather be cold or whether the weather be hot.
Be together whatever the weather, whether we like it or not.
Cool. Very creepy, yes. So that's always a great start for a presentation. So yeah, this model and this individual, a filmmaker, was able to deploy this AI model himself, actually on his local machine, which I'll talk a little bit more about as well, and generate essentially. This is actually using images per slide, so the video is just a series of images, and kind of overlaying that onto those creepy faces. But just to give you that, if that wasn't creepy enough. This is even more creepier. So this is a project called Project Follower. And we won't go too much into the world of AI ethics, but this model, essentially what it does is takes an Instagram photo and actually scans open cameras, so like security cameras that are open and anyone can view, which there are like hundreds and thousands of them, if you have ever done a Google search on those sorts of things. And it essentially takes an Instagram picture you see on the left and finds that person and in that video camera footage, and shows you kind of how the photo was taken. So from a more security or ethics standpoint, this is super creepy. Less creepy than the scarier guy. But as you can see, this individual is one there, and it can sort of identify everyone in the video, but then especially the person in the Instagram. So there's tons of examples of this. This again was an individual person working on this project, so not have some huge corporation, but you could imagine some government being very interested in something like this. So again, also using some of the power of AI. But the other kind of category we get a lot of is AI research. So mainly in the university side of things, but also big technology companies like, let's say, Microsoft, where we have large amount of people that have been dedicating their entire lives to studying on specific models. And they're really there, they produce papers, as you see here. And I think that's interesting as well, because it definitely pushes the envelope of the technology and what's possible. And we wouldn't get any of those creepy demos I showed you without the research. But it's also, I think, kind of abstract or far removed from most people as far as their understanding. I do encourage, if you are interested in AI research, there's a site called archive.org, and you can basically pull in almost any AI research paper out there and actually truly understand some of how these sort of models in the background work. And it's actually pretty approachable, especially if you have some basic knowledges of AI. And then the last like AI talk category I like to talk about or get talked about is like AI and enterprise. So these are, the enterprise companies. They have money to blow. Basically, they have huge investments, and they probably will pick a team of consultants out to build a huge, $1 million project for just a proof of concept AI project that will move the needle 0.001%, but that actually translates into millions of dollars of profits for the organization. And now this is a talk where whoever was responsible, the project manager, comes in and explains the ups and downs of that. And that's also a room and there's some place for that as well. Who doesn't like loads of money, and who doesn't love a team of consultants to do your bidding? But this, again, is not that talk. This talk is really going to be focused on AI for startups. And I think there's something specifically around startups and working with AI that I think is important. And that's kind of what I want to communicate here in today's workshop. So just a little bit about myself. I love AI. I've probably been working in AI for now about 4 years to solely focus professionally. But even before that, as an interest, it's always been some about technology that's fascinated me. Mainly because not only are those crazy demos that we see everywhere and what's possible with AI, but then digging deep down there and then having a lot of like aha moments, like I never really thought about it that way. And I think just as a society and as well as embracing the technology, I do think AI is a technology that can enhance our creativity, our efficiency as humans, and not necessarily replace them, as is the iRobot here aiming to do. So I don't think there's so I think it's a fascinating technology, and I think if everyone has, as mentioned earlier, the literacy of working with AI, you can also use some of the powers of working with AI. So I work at Microsoft, specifically in the Reactor space. So I like to start my intro saying that I don't sell Azure. So if you think, or you thought maybe you were afraid that this will be a Microsoft talk and we'll just go through all the Azure services and how you as a startup can use them, this won't be that talk. My goal as working in the Reactor basically is to educate the community as a whole. So the Reactor is Microsoft sort of give back to the technical communities that it operates in. So we have 12 reactors. Our reactor is actually located in central Stockholm in the Epicenter co-working space. So if you're ever by, please say hello. And again, we host technical workshops both in our space as well as doing stuff like this to really increase the education of really the community. And this is, you might sound like a dream job. So I do actually have some deliverables and things I do. So we do have a meetup group where we post all our workshops and discussions like that. I have done some other similar talks around building your first AI project that are a little bit more technical than what this might be. And just because I was allowed to do some shameless advertising, I do have a session coming up tomorrow actually on getting started with databases. So again, more technical side of things, but all tied to working with data and AI and how you as a practitioner or in working as a startup or either as a developer or even a non-technical person can get up and running with this sort of technology. So check that out. And like I said, my main audience is developers, students, and startups. So I do don't again isn't the the demo guy that speaks specifically to enterprises and talks about massive projects that we cost millions of dollars and save the world. But I do speak to a lot of startups, a lot of developers, and also students willing to learn AI and other technologies. So I'm super happy that this is the audience that I'm presenting to today. But yeah, feel free to join the meetup. We have the short URL here, aka.ms/suiteup. And if you are, I'm assuming in your home, you can scan that QR code. And of course, I will show this later as well, so you'll have time to scan. Outside of what I do at Microsoft, as mentioned earlier, I was working at a startup called Peltarion before this. I launched a startup accelerator program, which was a 6-week program, essentially where we took startups who were vaguely interested in AI. They had either a product already launched and they wanted to add like an AI feature, or they just had an idea and they thought AI could solve that. We took them through a 6-week accelerator program where we did workshops such as this, but then also using the Peltarion tool, which was a no-code AI development tool, actually build and deploy a model in their application. So the whole idea was to take basically people from stage zero of working with their AI feature or AI product and getting them to actually launch something. Outside of that as well, I hosted a podcast. I know a lot of people brag about their podcasting, hosting abilities and things like that. So I'm proud to say I'm a former podcaster. So you won't be able to find any episodes anymore. I pulled them. But it was a 10-episode series where I actually interviewed entrepreneurs and startups that were specifically building AI startups, because I thought it was super interesting that, again, a team of one, a team of two can actually build full-fledged AI products, which I don't think many people talk about, and what this talk will be about mainly. But going to specifically around startups, I think there's 3 challenges that most startups face when they're looking to work with AI. And this is, again, based on the conversations and experience that I have working with startups. And that is skills, data, and cost. So on the skill side of things, it's mainly, you might have a technical co-founder and maybe a business focused or commercial focused co-founder, and maybe a few developers on your team, but you don't maybe not have someone that's specialized in AI or a machine learning engineer or a data scientist. These people are very rare and they come at a high cost to employ. You might be a data scientist, which is a win-win. And again, it's a perfect match. But I think most startups don't have these skills and talent available for them, at least initially. As they grow and develop a project, they might look for a startup, someone that's specialized in AI. But again, from the earlier days, the skills is a big gap for most startups to embrace working with AI, and they just say put it off until later when they have more investment. On the data side, data is one of the #1 keys of working with AI, and we'll talk about a little bit more about what that means. But you don't really have the liberty of a company that's been operating for 10 years and collecting data on users or getting feedback. So you really are starting with almost zero data or very little data because your user base is so small. And if you're building a project that utilizes the user data in some type of way, whether it's not necessarily personal data, but the way that they use your product or historical data of how your product has been used, it becomes tricky if you don't have any data to operate with. So that's another sort of gap startups face and challenges. And then cost. Cost for not only operating a startup are high and getting higher every day sometimes, but even if you have funding, those allocation of funding probably goes to hiring people or marketing or building some business case. And AI tends to fall like at the bottom of that list of priorities at times if your product is not specifically AI focused, and it seems like, again, more of a dream for the future. So this talk will kind of be focused on these 3 key areas and how you can sort of overcome those challenges. So whenever you want to start working with AI, you say, I want to start building with AI, and I saw this talk that Korey did that was really good. Where do I go next? And normally it's a Google search of finding different AI tools that maybe can help you out. So you'll get something like this in your sort of search results, because this is a kind of market snapshot of 2021. So I can imagine maybe some of these companies have folded and some of the new companies have been added, but it's roughly the same size of this, where there's different AI or machine learning products out there to make your life easier. But actually choosing those products is not easier, because you have so much options, and you're probably left with so many choices, and no decision is made. You hope again, maybe in the next 5 years, we'll hire a data scientist to sort out this mess for us. But again, I think there's some guiding frameworks and ideas that once you understand what AI is good for, you can understand how to navigate through this landscape, because most of these tools are still very specialized in different areas of AI. And if you only focus on understanding your AI use case and what AI can do well, then this will make your time and your choosing of these things a little bit more efficient than just looking at all of the beautiful logos here. So what can AI do really well? I know I'm breaking all of the rules of great presentations by putting a large quote here on this slide, because there's probably no chance you will read this before I do, but I will highlight, I think it's a really great quote, so that's why I have no shame of including the whole thing here. But the main idea is that if you need to imagine, if you understand how AI or machine learning works, that there is no such thing as machine learning, that it's just all a fake, a hoax, sort of a Wizard of Oz type of environment where there is someone behind the curtain operating and actually doing all of that work. And oddly, many AI startups have said that and alleged that they're working with AI, but it is a team of interns or a team of underpaid workers, unfortunately, doing the AI work in the background for at least for, like, let's say, their MVP, as they say.
Also called human API.
Yes, the best one, the cheapest. But this is the idea of it, that if you want to understand that, let's say that you will have some task, or you have some feature or something that you want to implement in your product, and you would like to have somebody be able to do some that and find an input, and also take that input and provide a quick decision. And I think that is some of the, I guess, foundations of what AI does really well, is providing us quick decisions, or predictions in most cases, we say, to the task at hand, either for the user or for your product. But what are the elements of AI, and how does that process kind of fit into them? So there's 6 sort of elements here that we will talk about, a more broad sense of things. And again, on the Q&A, if you want to get more technical or ask more details on these things, I'm happy to talk about them. But on the machine learning side of things, there's kind of some classic machine learning or even classic statistical models that are used. One is the classification model, and this is classic, as no pun intended, a classic case of using a model to classify whatever sort of inputs you give it. The typical example that most people understand is the spam or no spam email. So you're taking inputs. Let's say the model considers when the email was sent, where it was sent, if the subject was in all caps, and it determine, and if you've ever received the email from that person before, and it can then classify that email based on whether it's spam or not spam. And again, we're making predictions here, so everything a machine learning model does is based on probability. Regression is a similar. We're taking inputs, but we're also making a prediction based on what we think is going to happen in the future, essentially. So another thing is, maybe if you take, let's say, sales data, or data around customers and their actions on your website. Let's say they're returning customers, how much the price of the basket and cart is in there, what items that they've added in the cart, again, what time of day, and the model can sort of predict whether or not you think they will actually complete the purchase. So those are some also classic examples of using regression. And then clustering is an interesting one. It's really, again, grouping the inputs that you receive into a group that could be relevant for your use case. I'll give you an example of a project that I've worked on where we were trying to determine where the best place for a tourist in Stockholm to stay. So we took a lot of different data based on Airbnb data, like the available Airbnbs, how available they are, the cost of them, the size. We also took some location data around amusement parks or tourist attractions that are in that neighborhood, because I think there's like 5 or 6 distinct neighborhoods in Stockholm. And we clustered those neighborhoods. So we basically, all of those inputs, we clustered them, and we had a cluster of, I think, about 5 of the top 5 neighborhoods based on all of that data. So that's another example of like taking those inputs and then getting the decision around how similar these are. And then whenever there's a new data point, which is nice, you can also predict what cluster that new data point would be involved with. And again, judging about your product or use case that you're looking to apply to, this could be very useful for you, whether it's around customer segmentation or doing any general predictions around marketing as well. And then the last one I will go more into detail with is deep learning. So this is using neural networks. And I always love the explanation of neural networks, because most people just say it's neural networks and it's how the brain works. And they just assume that everyone will understand what they mean by that. But neural networks are basically interconnected models or layers of models where it can again make predictions on things that are, I think, more close to what we see, what we say, and things like that around the different models. So we'll go into more detail on those models as well. Lost my cursor. So one of the deep learning use cases or areas of study is computer vision. So computer vision can really specialize in 3 different areas. Image classification, so understanding what an image is actually of. So this image right here, I guess it's some sort of factory or machinery. And again, since we're working with predictions here, the model predicts what it actually sees as far as either a percentage of what's the image, or exactly what the model thinks the entire image is about. It depends on what model you're using. So in this case, it's saying, it's pretty confident that it sees scaffolding and some guardrail, and then also picking up water. And this is an interesting case, again, if you're looking for predictions based on images, as well as if there's, you could rank the amount of predictions as well. So let's say, okay, if the threshold of water reached 80%, maybe you have a flood in your machinery and you need to go send someone to sort it out. I would hope you maybe have some physical sensors on floods as well, so you can pick up water, but hey, AI can also help you do that as well. The next one is object detection. So the kind of input, again, is also images, but it can also detect specific things or boxes around those objects. So you can see here, there's little boxes around each bolt because it predicts that these are bolts. And it also gives you sort of a confidence level or probability of if these are in fact bolts. So you can see one bolt is the model is feeling really confident on, but then if you go into the image further, there's some darker bolts, or the image gets darker, so it's less confident. I worked with a startup working with drone technology using this. So again, doing object detection around what the drone sees in sort of real time, and specifically around smoke. So forest fires is obviously a big thing as the unfortunate climate crisis continues on and the world gets warmer. So using the drone technology and AI paired with that, you can detect smoke and understand, predict or warn people that there might be a potential forest fire brewing, because these things happen very quickly. And the last one is semantic segmentation. And it's also understanding what the objects are in, but less about the kind of, is this an object or is it not the object as in object detection, but more about where the object is specifically. So you can see in these examples, like the bear one here, I guess that's a bear or someone on the horse or a dog, is actually segmenting on a pixel level what those images are. And you can probably guess the biggest case for semantic segmentation is around like the self-driving cars or self-driving vehicles. Like how does the model sort of predict or know what's where, and if it knows it's a sign or it's a child or someone on the bike, and how does the car respond, the vehicle respond to that prediction. So the other big area for deep learning is around language, which is natural language processing, NLP. One of the ways AI can kind of work on your product or startup is around sentimental analysis, or sentiment analysis actually. And it's really kind of also understanding what are the sort of feelings of the text. One of the examples that constantly comes up for this is around customer reviews. So your customers are probably writing reviews on your product, whether it's on your website or on other websites. And instead of having someone go in and read all of those reviews, you can use a model to basically flag when it's a negative review. So the input is a review and the prediction is whether or not this is a positive or negative review. That's a classic example. I've seen sentiment analysis used in a very interesting case. A city here in Stockholm, or city here in Sweden rather, they have public daycare, the public daycare system here, and they actually had a kind of AI assistant to the daycare teachers, where students would come and they would feel kind of empowered. Whenever they had a lesson, they would run to an iPad and they could like review the lesson essentially. So it gives feedback to the to the daycare teacher. So they wanted to kind of up that level instead of having a form that no one loves to fill out a form, and especially kids. So instead of having a form, the kids would actually talk to the iPad or talk to the AI assistant. Then they would use NLP to understand what the kid had actually said, but then also provide a sentiment that goes directly into the daycare teacher. And this wasn't just, was this a bad lesson or was it a good lesson, but like generally how their feelings were they lost, were they confused, things like that. So it's a powerful technology if you're looking for use cases that are just not outside of the typical commercial how to make more money using AI. So I do employ you, if you are working in that space, to look for things like that, where you have customer or people interactions. And if they're important enough to you, how can you scale that more by using NLP? And then we have speech recognition, which I kind of already mentioned, but like what is being said. If I don't know if there's a transcript running here, but I'm sure this would be, if it was, it's using an AI model to understand what I'm saying. So you can pull the transcript here and not necessarily watch this video. You can just read the text, or for anyone who is hearing impaired, they can also see and be accessible for this type of presentation. So it's really good stuff. And then lastly, probably the most annoying AI I will talk about is the conversational AI. So this is your typical, keep on the Microsoft band here, I'm talking about Cortana. I'm not sure how many people use Cortana, but you probably use someone like Siri or Google Home or something to command your everyday, your home, your phone interactions, or at least try to use those. And that's also using NLP. And again, these models are even getting more accessible. So even if you're not Google, Microsoft, or Apple, you can still use a lot of the conversational AIs that are out there. This next one, I didn't really want to talk about too much. It's more of an enterprise case, but you could be interested if you happen to work at a startup and you do have lots of data to understand. But it's called knowledge mining, and essentially it's as enterprises, as if you've ever worked in a large company, let's say like Microsoft, there is data everywhere that exists in different places, whether it's SharePoint, databases, or someone's personal computer. And in order for a company to kind of understand that data or provide some sort of insights, you can take basically your structured data, whether it's, again, clear databases, CSV files and Excels and things like this, and even your unstructured data, so PDFs, let's say you've got contracts that are signed, and maybe videos from marketing and images from the sales team and audios from different podcasts that the marketing team has done. And you can essentially feed those all into the model, and it will give you some basic insights around search primarily, which is a big one, but then also around vision and language so that you can not only find that information that's relevant to you when you're looking for it, but then also integrate those into different applications like CRMs, ERPs, and the lovely Microsoft product Power BI, which gives you more business insights. So it's really just kind of making sense of all of the data that you might have. So again, maybe not as relevant to the world of startups, but it's always there. And if you're looking for a use case around that, that's kind of the space to look for. And the last one that AI is really good at is anomaly detection. So anomaly detection gets talked about a lot around different sounds. So one of the beautiful things around sound is that the AI doesn't actually need to hear any sound because you can put AI or sound into images and understand by the wavelengths if something has been different. So essentially what the model is predicting is has there been any change or any noticeable changes that come about with the sounds or even videos or things like that. So one of the examples, an odd one, but it was around kind of parking attendance and parking security. So in most days, like during the day, let's say, a parking lot may or may not be full, but taking the security cameras and let's say you can detect if we see an increased amount of activity, either more cars, more people or something in this security camera, the AI can detect this as an anomaly because it's seen all of the security footage for the past year, let's say, and alert, let's say, alert the attendant that there's some new, different or high level amount of activity here. And instead of having the attendant look at every single camera feed, I can only look at the most relevant ones. So that's another one. There's also around manufacturing is quite big. So machines make a lot of noise, and that noise is normally the same noise over and over and over again. But once it makes that like sound, it's a really bad sign. Instead of having, again, someone always listening in on that annoying sound over and over again, that person can only be warned once an anomaly is detected. So there's a lot of different things that can be applied to anomaly detection. It's a wide space. And again, you might not think that your use case has anything like that, but I've seen and heard some things that are like, wow, I've never thought of that around detecting anomalies. So again, another use case of understanding what AI is good for and seeing how it can be applied to your product or features. And this is probably the most talked about and one I enjoy the most is around generative models. So when I first started looking at AI, I foolishly volunteered for workshops such as this, where I had no idea what generative models were, but I decided, okay, I would love to talk about them because I think it's really cool when AI can create things. Because as you noticed, I talked about a different AI use cases where AI predicts things, and that's, I think, generally what most people accept that AI can do well. But when we talk about AI and creation, most people aren't necessarily as informed about the capabilities. And I think that's probably the next frontier, if you will, on what AI, from a human perspective, how we will be working with AI mainly. So the first one I'll talk about is adversarial networks. So this person here gave me expressed opinion to have their photo in this slide because this person does not exist. This photo was completely generated by AI. Basically what it does, it takes two AI models and competes against one another. One model has all the answers of this is what people look like, and another model is essentially saying, I'm going to try to make a person, and the model just keeps going and says, does this look like a person? Does this look like a person? And the model with all the answers keeps saying no until one day it gets fooled into saying yes, even though it's not a real person. That's a very basic explanation of how adversarial networks work. We're seeing a lot of this being applied to retail and e-commerce. So instead of having a designer design a complete full fall wardrobe, you can have an adversarial network design a wardrobe and then put it out into your website, for example, and see which ones get the most traffic, and those are the ones maybe you actually produce. Again, saving a lot of efficiency, but obviously the designer might be still in the loop in the process to approve or make sure that these designs actually make sense. The other two are quite popular, and even from a Microsoft perspective, if I will, on talking about generating AI or text and images. So one is GPT-3. I assume everyone has heard of GPT-3, but I also talk to many people working in AI. So maybe my bubble is not the general populace. But if you haven't heard of GPT-3, it's a model essentially was made by a nonprofit called OpenAI, and it trained on an insane amount of data from Reddit, where you can now essentially give the AI a prompt. Let's say, is pineapple a good pizza topping? And the AI can generate a response, whether it's a good pizza topping, for those who like sweet and savory flavor combination. So again, it kind of understands the context of what pizza topping is, the flavors, things like that, because the way this model has been trained. This is a now open API, so you could in fact use this if you'd like. At least test it out in Sandbox. There's cost, which we'll talk about later as well. And there's even open sourced versions of this called GPT Neo, which is also worth a look at if you want to really get your hands on something like this. It's opening a space what most people think is going to be like the next kind of job within AI is called prompt engineering, where designing these prompts, for instance, is a skill in itself to get the sort of responses that will be useful for a product. I have at least heard of talking about different use cases around using GPT-3 for, let's say, storybook or story creation. You can type in like once upon a time and GPT-3 will fill in the blanks and start a story, and you can continue on like that, which also brings us to the next model I'm talking about, which is DALL-E 2, which takes the same sort of prompts with text, but actually generates the images. So you can see here a realistic photo of oversized grizzly bear posing for his grad photo on campus. And the AI was able to generate those things. And it can do things like style transfer. You can say this like in Van Gogh style, and it would also generate that. It can also remove things. It can add towards things. So if you wanted to add another thing in this, like his professor, his giraffe professor, it could easily do that as well. So again, how do we use these technologies in a way for creation, and how do we make them accessible is a kind of the new space that many people are talking about. So it's a really nice area to explore, especially as a startup and you want to kind of scale your production or efficiency. But now that we've talked about what AI is good for, like okay, we're ready to build, like where do we start or where should we go with things? And I like to say there's quite a lot of different steps on how to do AI well. We'll focus on basically the top 3 here about framing the problem and getting the data, because I think those are, again, really, once you get those sorted well, these other things around data cleaning, explorations is a very technical topic. Picking the right tools becomes much easier once you understand the use cases that you're applying it, and model training and analyzing the results, as well as testing and model evaluation, can also be, depending on the tool used, completely streamlined and decided for you. So again, you don't necessarily need to be a data scientist or machine learning engineer to employ or deploy AI models into some products. And again, depending on your tool, deploying could be easy as clicking a button and having an API for you to get predictions from. So I won't focus on those because I think from a general area, most people stumble on the first 2. But framing the problem. And that is really the first question, is how AI can actually solve this. I told you just now around how what AI models are good for, but like how does this actually apply to the problem at hand, or where do we use the predictions and how? The other question I always like to say is like, can I solve this another way? I told you again, my intro, I love AI and I think it could be used for everything, but there's actually times when AI isn't necessary, specifically around automation. Or I'll give you an example. We were working with a recruitment company, and they basically wanted, once they got a like a job description, for AI to take that job description and then post it in all of the different job boards. This is a simple automation problem. Where you could write a Python script in probably 6 hours to do this, and you don't need AI to do that. But for the people, they just thought AI would do this. This is an AI problem, so they were ready to sort of invest and work on building an AI model when it wasn't really necessary. So in cases where you think you might have a problem that AI can solve, always look at for other ways that maybe things can just be simply automated. If in fact, like you wanted to take the job description and predict what job it was, or predict what salary, or predict, maybe match candidates by a prediction of that, that's an AI problem because it's dealing with some sort of prediction or with the inputs that you're having, and not necessarily just doing some process automation. The next is like, how will the predictions be used? And this is really important because, like I said, the general outputs for every AI model is a prediction, even if it looks like it's something like the DALL-E 2, where it's a full image. The model is still predicting that it thinks that's what you wanted. Even so, it's still always going to be, how do we now use these predictions in our process or our product, whether it's being a driver or driving the process. And what I mean by that is, let's say, example of in manufacturing where someone might get a prediction. We were working with like a robot manufacturing startup, and they wanted the model to predict when the robots needed maintenance. And they have all these data points around where the robot is located, the temperature, of the robots, things like this, because those are all indicators of when maybe the robot needed to be fixed. And now the model will make a prediction. The robot needs to be fixed. So now, do we automatically send someone out there to fix the robot, or do we have, or do we, ship parts to the robot? It's all a matter of like, does like a human then use those predictions to take an action, or does an action automatically get automated there? Another kind of more grim example, I was working in, is just to prove that AI can be applied everywhere. We were working with a slaughterhouse that basically wanted to use the meat carcasses or the bodies of the animals come, and they wanted to predict how much fat was on the animal. And they had everyone in the slaughterhouse take a photo of the animal, and then the model was going to predict, oh, this is like 6% fat or 20% fat. And then I asked, what are you going to do with those predictions? Is it that you're going to throw away the ones that aren't fatty enough or too fat? And so again, that's all important to consider, because when you're looking at for the next part is like, how will the world look after? Like, how much improvement do you actually want from the model? Is it for some businesses and products, a 2% increase in efficiency, as I mentioned earlier, could amount to millions of dollars of savings or profits because of the saved time or the efficiency it has. But it's good to be realistic about the improvements that you expect the AI to provide in your product or your process, so that you can define success early on, and you don't just go around spending time and money deploying or training different models and not getting the results you expect because you never really defined what successful looks like. I know as a beginner, it's kind of hard maybe to understand how much improvement we can get from an AI model. But I always like to say, if you have a baseline of how a human is doing this, so if a human is taking 30 days to look through all of your CVs, for example, to determine which ones are best candidates, and now the AI model can do that in 3 days, maybe that's a good metric or good time saving. So always looking at your existing processes or the status quo and using that as a baseline to understand how well you want the AI to improve that. And again, you might not always hit it. I mean, a lot of AI projects, unfortunately, die in proof of concept world, but it's always good to have that defined, because if you don't, it's much more likely you're going to ditch your AI project much quicker because you just didn't have any either realistic expectations or set expectations on what the model could improve. So data, that's another kind of, again, key blocker, because like I said, startups, you might not have data available for you, at least internally, where you could start training the model. I'll talk about how much data you might need to train a model and things like that, but data is normally another stumbling block, and why startups definitely push their AI project for later on.
Sorry, I have to interrupt you. We have 15 minutes left, which are supposed to be for Q&A. So I'm going to leave it up to you how to navigate this.
Yeah, I'll take 5 more minutes and then 10 minutes for Q&A.
Perfect.
I didn't know I was going to speak this long, but this is good.
Yeah. Awesome.
So data, yeah. So the good news around data now is that you need less and less data. there's this concept called pre-trained models. So like I mentioned, GPT-3, for instance, was trained on billions and billions of data points. So then once you're working with GPT-3, either if you want to use it as it is, or also pre-train, train it for other sources, can save you a lot of time and cost. Data can be related to your product and customer. It doesn't have to be specifically about your product and customer. So I'll talk about different other sources you can get data. And data is everywhere. You just need to find a way to sort it, which is actually the major work, cleaning it, sorting it, and having it AI ready for the model to process. So finding data, you can create your own. If you're a developer or non-developer, there's actually different tools and libraries out there that can easily scrape data, or you find data that are publicly available. There's free data sets. So you can use a company like Google has a data set search. There's Kaggle that has free data, which is used by data scientists mainly for programming and exercises, as well as governments like the Swedish data portal also provide data that might be relevant to your product. Again, it doesn't have to be specifically your customer data. Most of the time, this is like anonymized and useful for any AI model. So cleaning data, like I said, that's the most important. And we got a lot of questions about how much data do I need? And it's really a question of quality and quantity. And this could be a whole presentation in itself. And specifically, since I only have like 10 minutes left, it is going to be a whole presentation in itself. So last shameless plug of my own content. I will actually be next week giving a talk like this called Your First AI Project, called I'm Working with Data, where I talk about the balances of quality and quantity and how you can actually work with data there. So there's another plug for you. And then cost. Costs are going down. You can see here the OpenAI actually reduced their price recently on GPT-3, which is probably one of the most expensive models to work with, which is really great. And even if you didn't use a public model, you can actually run some of these models on your own computer if you have like a GPU or an M1 Mac that has a GPU, for example. So the costs are actually going really down. And there's a lot of other, again, no-code tools that you can use that really keep the cost and resources needed to a limit. But yes, start small. This is some advice. Just start small, start simple. Simple models still can solve big problems. Even like a simple regression model can reach to your customer and give you the predictions that you might need. Use no code when needed. There's tons of no code. If you just search no code AI, where you can implement faster on these models and learn faster on how the models are working and how you can sort of improve it. So it's definitely worth a look, even if you are a developer or technical. No code tools will just save your time. And then find the most impact. There might be a specific feature or a customer segment or a type of problem that you want to solve. The AI can help the most. And instead of just saying we want to do an entire AI product or feature, just focus on that and see how to improve it. Whether that be a proof of concept or, again, segmenting your customers off or a feature set is another good way to get things going. I'll save it now since we don't have much time, but there is some inspiration here. There's some different entrepreneurs and startups that I've talked about that have done some things as solo founders. This individual basically built a model that helps 3D printers basically don't burn down their house, because the 3D printing takes a long time. And instead of having to sit down there and watch it go, because these get really hot, this model basically shows when there's things called spaghetti, which is when the thing that you're 3D printing is kind of going crazy and causes a lot of harm. So it can predict that using object detection. And this individual is using AI to generate quizzes on GPT-3. And then lastly, this person, Robbie, is using GPT-3 to create better sales introductions and startups. That's probably a big thing as far as growing your customers, where they actually took GPT-3 and then also fed them LinkedIn data and market data. So if you want to introduce someone to, let's say, Microsoft, the model would also pull in recent news from Microsoft and design their introduction in a way where you can also, it will provide relevant information for your contact. And again, making that way more efficient. And it actually makes some promises of the amount of bookings you will get based on that. So that's it. Good luck. I'm here now for questions, and I guess we'll have a little chat as well. But you can also find me in these places on Twitter and on LinkedIn. If you do have any questions, I'm happy to chat and help out.
Great. I'm going to be launching a poll quickly. It's 3 questions, but you guys can go ahead and ask your questions already.
Awesome. Thanks so much, Korey. Jacob, you raised your hand. Please feel free to ask your question. If you can turn on your webcam as well, that would be awesome, if possible. Jacob? No questions, just waving your hand. Maybe
Hello.
that was, yeah, hand waving. All right.
Yeah.
While Kat push the survey to get your feedback, which is important to us, and feel free to think about specific question that you want Korey to answer. I'm gonna jump in with a question until someone else does, and keep asking until someone else wants to get involved here. You mentioned like obviously finding the data is important, and there are a bunch of ways to get pre-trained data to help you get started. I have a question that is more on the ethical perspective of having also existing data, a huge amount of data trained, for example, on Reddit, one of the most racist platform on the planet, right?
Yeah.
How do you know if the way the AI is trained is on an ethical way without any bad biases?
Yeah, that's a good point. I guess the first start is like, knowing where you're getting your data from. So generally, if you're getting a data set from the internet, it will probably give some sort of source of that. And obviously there's some techniques around exploring the data. So you can see as an, person, maybe an ethical, assuming you're an ethical person, I don't know, that, okay, maybe this data is not necessarily the best data set, or you can see sorts of things like that. So that's probably the start of it all. There's also a field of study called explainable AI or explainability, where it's actually showing ways, different other models that can show you how the model generated or made certain predictions in its weight. So that's also another layer of ethics that could be used, where you can actually see why the model made these predictions and what the model is focusing on. So there's kind of, at the beginning of the stage of your project, you want to make sure you're using good data, because bad data will always result with bad results. And then at the end of the actual training, trying to find some explainability frameworks so you can understand how the model is predicting it. But yeah, very good point. And the world of AI ethics probably deserves its own talk, to be honest.
Yep. Thanks for that. Annika, go ahead.
Yeah, hi. Dramatify is working with entertainment, drama, pre-production and production. We have gotten some actually customer requests regarding what you call script breakdown, where you have a large amount of text and you want to pick out certain keywords for future work. So my question is, how good is the classification on multiple language on different languages other than the sort of world languages? Because we get, Azerbaijani and smaller, including Swedish, sort of smaller languages. So because we need to pull out mainly adjectives and substantives, so red dress or fast car or things like that.
Yeah. So the bigger NLP models that are out there, the one is called BERT, B-E-R-T, is trained multilingual. They normally train on, I think, around 300 something languages.
Okay.
So,
yeah, that will suffice.
Yeah, probably.
I think.
But it's actually, just to talk a bit about the point, though, there is also other languages that are out there that either haven't been written down very long, or have loads of dialects, right? So there's a specific, people have taken this BERT model and applied it to those specific languages. So you could actually get a BERT model that's really good at speaking Swahili, for example, or understanding Swahili. But you probably want to start with a BERT and looking at training that. And that's like a model that's been used quite often. It's tried and true. So yeah, depending on what your skills and resources are, I would look at that.
And how good are the language, I would say, comprehension of a piece of I would guess you could say it's a version of sentiment analysis, which has to do with expense, actually. So if we would train a model to say, so instead that this is a happy text or a sad text, we would get, is it expensive or cheap to produce? So that's something you think that would be possible to do based, of course, on training and certain keywords?
I would ask, not knowing the space, but like what determines if a text is expensive or cheap to produce? Or is it the length or is it?
No, not really. It's you know, special effects, car chases, fight scenes, you know, that kind of very specific items. Just the dialogue, you and I talking, that's cheap.
Yeah. I mean, there could be certain labels that the model could predict based on the text. It's always going to be how you could train that model on. So if you had data that had a list of these are you know, expensive text to produce and these are cheap text to produce, let's say just in that one or the other kind of world, that could be a case for AI to understand. I'll give you an example where it gets tricky. I was working with a company that was doing dream interpretation. So they basically have an app where you wake up, you read to the app, like you tell your dream, and then it would try to classify, you know, if this was a scary dream, like a pleasurable dream. But dream interpretation has like 1,000 different labels that you could label it what it is. So a model will struggle with that if there's so many different options. Unless you have loads of data that also can predict, like, you know, train that on. So when we were working with them, it was really about, let's simplify these things first. And then like, as the product grows and your user base grows and you get more data, then you can provide more deeper level labels and predictions.
Thank you. Very clear.
Very cool.
Great talk.
Awesome. Good input. Is there a page, Korey, where we can find all the good links you shared during this talk, or should we just share it with the slide afterwards?
Yeah, we can share with the slide afterwards. That'll probably be easiest.
That makes sense. All right, we are soon ending this session. I think that this really helped me understand more about the opportunities of AI. I hope it also helped the attendees. And Korey, thanks so much for taking your time, sharing your insights. And we're looking forward to jumping on a fireside chat. I'll send you a link separately over email to get that started. So if anyone want to hear more, me and Korey is going to jump on a fireside chat. You can follow that on LinkedIn or Facebook in a couple of minutes. Thanks so much, everyone, for tuning in.
Thank you.
Bye.
Bye.
Great talk.
Thanks.
Thank you.
Thank you.
Thank you.